Hey everyone, welcome back to BugNoJutsu. In today's video, we're going to solve an interesting problem from LeetCode, maximum area of longest diagonal rectangle. This is a neat geometry plus comparison problem that looks simple at first glance, but it has some important details that we need to get right. I'll walk you through the problem, explain it with examples, share my thought process step by step, and finally talk about the time and space complexity. So stick around till the end because I'll also share some insights that can help you think about similar problems in a smarter way. We are given a list of rectangles, where each rectangle is represented by two integers, its length and width. For each rectangle, we can calculate the diagonal using the Pythagoras theorem, which is basically the square root of length squared plus width squared. The task is to find the rectangle that has the longest diagonal. Once we know which rectangle has the longest diagonal, we return its area. But here's the twist: if there are multiple rectangles that share the same longest diagonal length, then we don't just pick any one of them. Instead, we return the rectangle among those with the largest area. So the problem has two layers: first, maximize the diagonal length, and second, use the area as a tiebreaker. Let's take an example. Suppose our input rectangles are 9, 3, 8, 6. For the first rectangle, the length is 9 and width is 3. Its diagonal is calculated as the square root of 9 power 2 plus 3 power 2, which is the square root of 90. That's roughly 9.48. For the second rectangle, the length is 8 and the width is 6. Its diagonal is the square root of 8 power 2 plus 6 power 2. Which is the square root of 100. That gives us exactly 10. Clearly, the second rectangle has a longer diagonal. Therefore, the answer is the area of that rectangle, which is 8 times 6 is equal to 48. This example shows exactly how we must calculate diagonals and then compare them to determine the winner. Now let me explain how I solved this. Instead of actually calculating the square root for each diagonal, I realized that it's not necessary. Since the square root function is monotonic, the order of comparison doesn't change whether we compare the actual diagonal lengths or their squared values. So instead of computing square root of w power 2 plus h power 2, I just worked with w power 2 plus h power 2. This way, we avoid dealing with floating point numbers and potential precision issues. I loop through each rectangle, compute the squared diagonal, and compare it with the maximum one I've seen so far. If I find a bigger diagonal squared, I update both the diagonal and the area. If the diagonal squared is the same as the maximum, then I check the area and update it only if the current rectangle has a larger area. This ensures we handle the tie-breaking condition correctly. By the end of the loop, I'll have the maximum diagonal squared and the corresponding rectangle's area, which I return as the answer. Let's quickly analyze the complexity. Time complexity: we are looping through all rectangles once, and for each rectangle, the diagonal squared and area calculations take constant time. So overall, the time complexity is O(n), where n is the number of rectangles. Space complexity: we are only storing two variables for the maximum diagonal and maximum area, so the space complexity is O(1). Here's the interesting part. Problems like these often involve square roots, but you should always think if the square root is truly necessary. If the problem only cares about comparison, you can just compare the squared values. This avoids floating point operations and makes your code more efficient and cleaner. Another insight is about tie-breaking logic. Always pay attention to problem statements when they say if multiple, then choose the one with maximum area. These details are what separate a correct solution from a wrong one. In contests and interviews, getting these conditions right makes all the difference. And that's it for today's problem: maximum area of longest diagonal rectangle. We learned how to maximize diagonals, how to break ties using area, and why comparing squared diagonals is a smart trick. I hope this explanation helped you understand not just the solution but also the reasoning behind it. If you enjoyed this video, don't forget to like, share, and subscribe to BugNoJutsu for more LeetCode problem breakdowns and programming insights. Thanks for watching, and I'll see you in the next one.